Kia ora Year 11 and any Year 12s who are watching this. This is revision on algebra for people in AS. What I'm going to do is go through the questions in your Algebra and Functions test. So if you're in my A-level class this year and you're watching this by accident, you can keep watching because it's really good algebra revision for you guys as well. So I'm going to do one slide per question. I'm going to go reasonably quickly and we're going to cover quite a lot of skills. This video is going to have all of question 1. And then I'll do another video for the later questions in the test. Okay, so the first question is just a simplifying surds one, which is the square root of 32. I'm going to do this one quite slowly so that you get the idea with surds again. So when I'm working with surds, I'm always on the hunt for perfect squares. So I can think of root 32 as 16 times 2. And then I can think of that as the square root of 16 times the square root of 2, which gives me 4 root 2. Once we get good at that, we don't need to do, certainly don't need to do this step. For example, if I had the square root of, let me think of one, a good one, 128, I would look for a square in there, and I might think of 64 times 2, and then I'd get 8 root 2. Okay, so whenever we're doing anything with surds, we're always on the hunt for perfect squares hiding inside the number. You'll see that in the next couple as well. So number 2 is B is 2 root 20 times 3 root 5. So what can we do? Well, we can reorder it and we get 2 times 3 times root 20 times root 5. So this time we're putting the surds back together. And we get 6 root 20 times 5, which is 100, which is 6 times root 100, which is 10, which gives me 60. Right, on to question C. So here we have to expand brackets, and it's just like when we do expanding with algebra. So we get 6 plus 4 times root 3 minus 2 times root 3 times root 3. That gives me 6 plus 4 root 3 minus 2 times 3. Right, root 3 is 3. So 2 3s are 6. So my final answer here is 4 root 3. On to D. Right, so we're back to this idea of hunting for perfect squares, or square numbers, when we're working with surds. So I'll do this slowly, and then I'll do it quickly. So we can write root 12 as 4 times 3. And we can write root 18 as 9 times 2. Notice that here, the factors that I picked were not 3 times 6. That's not going to help me. I picked 9 2s because 9 is a square. And up here, I picked 4 3s, not 6 2s, because 4 is a square. So now we can simplify that as 9 times 2 root 3 over 2 times the square root of this, which is 3 root 2. The 2's cancel out because they're a common factor, and 9 and 3 simplify to give me 3. So my answer here is 3 root 3 over root 2, and I could write that slightly more elegantly like this, 3 times the square root of 3 over 2. So let's formalize the rule that I'm using here quite a lot. The first one is that the square root of a times the square root of b is equal to root ab, and the second one is that the square root of a over the square root of b is equal to root a over b. And that works not just on square roots, but on any power here, as long as they're the same power. So we make that the kth root. Okay, so it works for cube roots and fourth roots and so on. Now, the next one is a nice example of a surd, quite a messy surd, times a conjugate surd, right? Notice that here I've got a minus and here I've got a plus with basically the same numbers. So you're going to see a nice pattern come when I expand those out. So when we expand these, it's just like when we learnt expanding simple quadratics back in year 9. We take this and we times it by this. And then we do these two and so on. And these two, and I'm missing one, this one here. So off we go. And you'll spot some simplifying patterns quickly. So the first two give me 16 root 3 minus 4 root 2 root 3. Right, that's from, let's highlight it, those middle two there. Now what? Right, now we're going to do the ones on the end, and we get plus 4 root 2 root 3. Okay, so that was this one times this one, and that leaves me with 1 to do, which is the ones on the end, so minus root 2 root 2. Now I've done that really slowly, but pretty quickly you'll be able to do them a bit faster. Here we've got 16 times 3, so that's 48. This and this go together to give me 0, so minus 4 root 6 plus 4 root 6. And then I'm left with minus root 2 times root 2, which is 2, giving me 46. Here's F. Now, this is a classic thing that we do when we're working with surds, and next year you'll see it with complex numbers, which is that we don't ever like having surds stuck in the denominator. So we have to somehow get any surds into the numerator of my fraction. And the way we do that is that we use the conjugate surd, and we call this rationalizing the denominator. Okay, so we take whatever we've got here, and we just change it so that this is a plus. And we can do that because we can multiply any fraction by 1. So up here, we've got the same thing in the numerator. Now what does that give me? Well, let's work on the denominator first. This times this gives me 9 root 5 minus 15 root 5 plus 15 root 5 minus 25. Right, so where is this 15 root 5 coming from? Well, it's coming from this one times this one, and then let's change pen colour, and then this one times this one. And you'll always get that pattern where you have a minus and then a plus. That's the whole point of why we do it. Now what does that leave me in the top line? Well, I've got 3 root 5 plus 5, but we've got some cleaning up to do. So my denominator is 9 5s are 45 minus 25, and up here I've got 3 root 5 plus 5. So let's simplify that now. What have we got? Well, this is 20, so we have 3 root 5 over 20 plus 5 over 20, giving me, I can leave it how it was, or nicer is to write 3 over 20 times root 5 plus 1/4. Okay, now we're into some questions on fractional and negative powers. These are really important for both AS and for level 2 algebra. So what do we do here? Well, the first one is the same principle as what we've been used to all along since year 9. We take our numbers and we multiply them together. We get 12. We look at these and we've got the same base, x, so we can simply add the powers, giving me 12x to the power of negative 1, and it's nicer to write that as 12 over x. Okay, h, same kind of thing, a little bit muckier. There are several different ways you can go here. You can either do all of your expanding on this and then simplify, or you can muck around with the negative power first. So I'm going to do this question 2 different ways. The first way is I'm going to basically expand the brackets, or apply the negative 1/2 to everything. So I get 2 to the negative 1/2 times x to the power of 2 times this. So 2 lots of negative 1/2 gives me negative 1. And then I've got y to the power of 4 times negative 1/2. So here, this gives me y to the power of negative 2. And in the denominator, I've got 2 to the power of 3 over 2 times x to the 3 over 2 times y to the negative 3 over 2. And I can clean this up by remembering that if I've got 2 to the x over 2 to the y, we've got the same base, so we subtract the powers. So what does that leave me with? Well, here I've got 2 to the negative 1/2 minus 3 over 2. X to the negative 1 minus 3 over 2, and y to the negative 2 minus negative 3 over 2. So we have 2 to the power of negative 2, x to the power of negative 5 over 2, and y to the power of negative 2 plus 3 over 2, so negative 1/2. So everything's in the denominator, right, because I've got negative powers. So this is going to be 4 down here. This is x to the power of 5 over 2 and y to the power of 1/2. And I've got 1 sitting there in the numerator. Right, now let's just have a look at another way we could have done that. So that's fine. It's a perfectly good way to go. But I'm going to do this one again. So let's write it out again. 2x squared y to the 4 negative 1/2 over 2x y to the negative 1 to the power of 3 over 2. So this time I'm going to deal with this by chucking everything down to here, and I get the following thing. I'm speeding up because, sorry, background noise. Never mind. I'm just about to stop and have dinner. There you go. Okay, so now we're going to expand all of that out. And we've got no negative powers except for one little one. So we've got 2 to the 1/2, x to the power of 2 times 1/2, which is x to the power of 1, y squared, times 2 to the 3 over 2, x to the 3 over 2, y to the negative 3 over 2. And now I'm just dealing with adding up powers as follows. So 2 squared x to the 5 over 2, y to the 1/2, which gives me what I had before. So there's not really any big difference. I just want to make sure that you're comfortable with both of those methods. Okay, I've got 3.5 minutes to get through the last 3 little log questions before the video runs out. So here we go. So very quickly, here we're using a log rules, which is that the log of AB can be split up as the log of A plus the log of B. There's one other thing that makes this question easier, and that's that the log of 1 means what the log of 1 is always equal to 0. So why is that? Well, if I've got the log to any base, anything to the power of 0 will give me 1. So as soon as I see log 1, I know that that's 0. So what have we got? Well, log of 3 plus log of 2 plus log of 1 is equal to just the log of 3 plus the log of 2, which is equal to the log of 3 2's, which is the log of 6. And that's the end. So we don't care about the base here, right? It just doesn't matter. It could be any base we want. Next one, same idea. The rule we're using here is that the log of a to the power of b is equal to b times the log of a. So let's have a look at what log of 16 is. So log of 16 minus 2 log 4 is equal to, well, let's just leave the log of 16 like that. And now we're going to put this one back into this form. So this is log of 4 squared. And that's the log of 16, take away the log of 16, which is 0. Okay, on to the last one. Right, log of 64, well, 64 is 2 to the power of 6. And the log of 32 is 2 to the power of 5. So we're going to use our power law again. 6 log 2 over 5 log 2, which simplifies to give me 6 over 5. So there you go, 1.5 whole minutes to spare, and I'll be back with a little bit more later on tonight. I'm going to try and do question 2. If there's anything in here where you want more revision work, if you want to leave me a note in the comments, and we can come up with some more examples of different question types. Thanks for watching.